In this video, I'm going to go through the answers for the Chapter 8 practice problems that I posted. So this is all going to be reading the graph that is on here. And the first question says that most things increase their solubility as the temperature goes up, and we can see that from the graph. But they want to know if there's any that decreased. And I found two. There's NH3, here's one of them, and then there's the Ce2SO43. So that's what I have for the first answer. And then in order to read the graph, it says at 30 degrees, approximately 10 grams of KClO3 will dissolve in 100 grams of water. If the temperature is increased to 80, they want to know how much will dissolve. So I'm going to go to KClO3, which is this line, and I'm going to find 80 degrees. And if I go up and read it, I'm going to find out that's about 40 grams. And that's what I have written in here. And so then we're going to practice on these. So we want KNO3 at 70 degrees. So I'm going to go KNO3, and then I'm going to find 70 degrees. And if I go over, I should be able to read that it's about 130. Next one is NaCl at 100 degrees. So I'm going to go to NaCl and 100 degrees, and it looks like it's about 40 grams. And then NH4Cl at 90. So I'm going to find NH4Cl and go to 90, and it looks like that's around 70 grams. And then of those three substances, which one is the most soluble at 15 degrees? So here would be about 15 degrees, and if I go up, then I can find out that it's going to be the NH4Cl, because it's the one that is the highest line. Alright, so now we're going to read this and figure out if things are saturated or unsaturated. So on the lines, that's going to tell us if the solution is saturated. So that's going to tell us the maximum amount that will dissolve. If it is below that value, then it's going to be unsaturated. So for the first one, we have a solution that is NaNO3 at 30 degrees. So I went up to my NaNO3 at 30 degrees, and then I went over here, and it looks somewhere between 90 and 100, and I said it's about 95 is the solubility. So if I'm going to put in 70 grams, that's less than 95, so it'd be unsaturated, and the difference between those would tell me how much more I could dissolve, which would be 25. The next one, it wants to know KClO3 at 50. So I'm going to go back up to my graph, and I'm going to find KClO3 at 50. So here's 50, go up to KClO3. It's about 20 grams. So the solubility is 20, and I'm going to add 20, which means that's the same amount as my solubility, so it's saturated. The next one is Ki at 0 degrees. So I'm going to go up and read my solubility. So Ki at 0 degrees is not quite 130. So I said it was 129. I'm only going to add 70. So that means it will hold more than 70. It actually holds 129. So it's going to be unsaturated, and the difference between those, 59 grams, tells me how much more to hold. Now the other part of Chapter 8 was figuring out concentrations with all of our formulas. So the first one is percent mass by volume. So I'm going to put the mass of my solute over the volume of my solution, and that's going to equal my percent. So the first thing I did was change this percent into a decimal, and by moving it over 2, so 0.06 equals m over the 275, and multiplying those two, and that's going to tell me my mass that I would need, which is 17 grams. The next one, I have a percent volume by volume, so it's going to be volume of the solute over volume of the solution. So 25 over the total. So 25 divided by 175 times 100 is going to be my percent, and I got 14%. Next one is molarity, and for molarity I have to take moles divided by liters. So I need to convert this grams into moles. So I took the grams, divided by my molar mass to get my moles. Then I take moles divided by liters, and this is milliliters, so I had to move the decimal over 3 to get it in liters, and I divide those, and that's going to get me my molarity. So 0.36 molar. Next one is another molarity problem. In this case, this is my molarity, and this is my liters. So when I multiply those, I'm going to get moles. So I got 1 mole. And to go from moles to grams, I need to multiply by the molar mass, and potassium nitrate is KNO3. So I added up a K, an N, and 3 O's, and got this 101. So 1 times this molar mass is 101 grams for 3 significant figures. The last one is a dilution, and that's because I start out with sulfuric acid and I'm making a solution that has less concentrated. It's only 6 molar. So I'm going to do the M1V1 equals M2V2. So 18 times I don't know what. And then on the other side I have 6 molar and 250 milliliters. So I multiplied those and divided by 18 and rounded to 2 significant figures. So it's going to take 83 milliliters of this 18 molar solution, and then I'm going to dilute it up to 250 milliliters with water. And that would make my dilute solution. So those are some examples of problems that you're going to find in Chapter 8, things that would be similar to that on the test. In addition, on the test, there will also be things from Chapter 7, and if you look on Blackboard, there's a list of all the things that are going to be on the test.